All right, we're going to be looking at the back of this worksheet, the conic sections ellipses. And back here is our old review, our mixed practice. So it's asking us to factor for this first section. And so remember, when we're being asked to factor, that our answer is going to be with some parentheses. We're not solving all the way. So it's giving us some hints that we might have to use difference of squares, the x problems, greatest common factor. You might want to use the method of greatest generic rectangles. So here we go. First one has x squared minus y squared. This is also known as the difference of two perfect squares. So we know that x times x makes x squared, and that y times y makes y squared. So how could we make it so there's no middle term, so that the middle term cancels out? We want one sign of each. That means that the middle would make a positive xy and a negative xy that cancel out. And so those are our factors. What are ones that we're familiar with that we've done this year? It was like x squared minus 9 with a number at the back. And that would be x plus 3 and x minus 3, so that the middle term cancels out. So this one just has an x and a y instead of an x squared and a number. Okay, the next one is also the difference of perfect squares, where you ask yourself, what times what makes 36x? I'm going to run out of space here. Hang on. And what times what makes 49y squared? And then there's no middle term here, so what signs have to be there to make sure there's no middle term? It's 1 plus and 1 minus. Now this next one is a perfect square, meaning that at the front, we still do 2x and 2x, that makes 4x. And at the back, we still do 3 and 3, that makes 9. But why is there a middle term this time? They have the same sign. This would make 6x, and this would make 6x. And 6x plus 6x equals that 12x in the middle. Notice I want both to be positives for that reason. So this time there is a middle term. What's the shortcut way of writing this? We sometimes would write it as 2x plus 3 squared. So that's why it's called a perfect square. Now this back one has an extra x all the way through, meaning including right here. So we're going to take a greatest common factor first out. We take an x out. That leaves us x squared minus 20x plus 100. We've divided an x out. Now on this back part, we notice that it is a perfect square as well. X times x makes x squared. 10 times 10 makes 100. Negative 10x and negative 10x make the double middle term of negative 20x. What's a shortcut way of writing this? We could say x minus 10 squared. So again, these only wanted factors, so all of your answers are done with just these parentheses answers. Okay, now the next section says solve for x. So factoring could be the way we solve, but after we factor, we want to keep going. This first needs to be equal to 0 or in standard form before I can try to factor it. What times what makes negative 21 and subtracts to give me negative 4? 7 and 3. Where should the signs be? 3 minus 7 would give me the negative 4. So my factors are going to be x minus 7 times x plus 3. That's still equal to 0. So now I can solve with the zero product property. I can set each factor equal to 0 and solve. I would add 7 to both sides here to get that x equals positive 7. I would minus 3 to both sides here to get that x equals negative 3. Here are my two solutions for that quadratic. The next one is also a quadratic, and we also want it equal to 0. So I'm going to minus the x and minus the 1 to bring that to the same side. So that's going to leave me 2x squared minus x minus 1 equals 0. And then again, we want to try factoring as our method, or else we can do the quadratic formula if not. But so if I try to factor this, I know that 2x times x makes my 2x squared. And I know that 1 times 1 makes my 1 at the back. But I need it to be a negative 1. So I need it to be a positive times a negative. This would make 1x. This would make negative 2x. 1 minus 2 is negative 1x is in the middle. So I have correctly gotten my factors. I could fully FOIL this to make sure. I set these factors equal to 0, and then I set each factor equal to 0 and solve. The first solution is x equals negative 1/2. The second solution is x equals 1. These are my two solutions for the quadratic. Again, using factoring as the method and then solving. The next one is just solving a square root problem. And how do I get rid of a square root? I'm going to square both sides to erase that square root symbol. So squaring the square root symbol is just going to leave me what's inside. And then 7 squared equals 49. This gives me 3x equals, and so we're just going to get a fraction. X equals 53 thirds. Yes, you can get me the decimal version of that too if you like. All right, we need to isolate the bars on this next one before we can solve with the absolute value. And I stop right here. Negative 10 divided by 2 is negative 5. Can an absolute value equal a negative? No. So this is one of those no solution sneaky problems. Over here, we want to minus the 5 and then divide by negative 1. Now I have that the absolute bars equal a positive, and I can continue this one. I'm going to solve 4 minus x equal to positive 3, and 4 minus x equals negative 3. And there's my two solutions. I get two solutions for absolute value problems because there's both the positive and the negative option. Next, I need to isolate the radical before I can do something with it. So I divide out the 2. How do I get rid of a cubed root of something? I need to raise it to a power of 3. Raising to a power of 3 anything that's cubed rooted just takes the x plus 6 out, and 5 to the third is 125. So I'm going to get x is equal to 119. All right, write the standard form of the circle equation. So let's go ahead and start our grouping. X squared, minus 6x, space, y squared plus 10y, space, equals negative 30. We go off to the side and do our B work. What's half of 6? 3. What's 3 squared? 9. Whatever I add to one side, I add to the other. What's half of 10? 5. What's 5 squared? 25. Whatever I add to one side, I add to the other. This gives me the x minus 3 squared, perfect. The y plus 5 squared, perfect. Negative 30 plus 36 just leaves me 6. So my answer to this is that the center is going to be at positive 3, negative 5, and my radius is going to be at root 6. How'd you do? All right, the next one says to name the vertex, the axis of symmetry, the focus, and the directrix. Because of timing this school year, I'm not teaching focus and directrix. You'll learn that in Math 3. But let's go get the vertex out of this vertex form. Remember that the x is the opposite sign from whatever's in here inside these parentheses, and the 2 stays the same. This is my h and my k, my vertex. And the axis of symmetry is, I want you to picture this. If the vertex is at negative 3, 2, the axis of symmetry is just that dashed line that goes straight down the middle of that graph. So it goes straight through x equals negative 3. This is called an axis of symmetry or a line of symmetry, and it's done in the form of the equation of x equals whatever that x value of your vertex is. So this is my axis of symmetry, and this is my vertex, and you should at least know those two things about a parabola, even though I'm not teaching focus and directrix. All right, write the equation of a circle below. So first we're going to identify that center. The center looks like it's at 3, 0, and the radius is at 1, 2, 3, 4. By the way, are these counting by ones? Yes. So it's just scaled by 1. So starting at the center, I count the distance to the edge of the circle, and that's 1, 2, 3, 4. So my radius is 4. Let's double check the other direction. 1, 2, 3, 4. 1, 2, 3, 4. Okay, my radius is 4 in all directions, so it is a circle. So now that I have my center and my radius, I can go ahead and plug this straight into the equation. X minus 3 squared, y minus 0 squared. Oh, I can just write y equals y squared, and then 4 squared is 16. How'd you do? Do you want to write y minus 0 squared? Does that make you feel better? Go for it. And that's the end of the worksheet. How'd you do on the back here?